Okay, welcome to question 3. All right. So this question 3 now, what does it say? It says that a set A, B, and C of the universal set U, which is this, are defined as follows. Set A, which is this. Set A says that it is set of S such that X is a prime number. Then set B says set of S such that S squared is less than 36. Then the set C says set of S such that X is an element of U and S is not an element of A. Now the question now says that we should list the elements of the above sets. Very important. So the above set in question here is nothing but the universal set A, B, and C. So we should just list them out. So in other words, this question is given to us in a set builder method, or we are given set of numbers in a set builder notation, and we are now asked to represent this set in the listing method. All right. Now, let me quickly explain, or let me start with set U, which is the universal set. Set U. So this is set of what? Now, this thing says that this is set of S, such that whatever thing S will be will actually fall within this range. That is, S will be greater than or equal to 6, and X will be less than or equal to 40. This thing can as well be read as that 6 is less than or equal to X, while X is in turn less than or equal to 40. Meaning that in this universal set U, whatever thing that is going to be the value of S is going to be natural numbers that will range from 6 down to 40. So very quickly, let's just write them out. It's going to be 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So this is set U, all right? So set U is set of natural numbers that ranges from 6 down to 40. No wonder we say that it ranges from 6 to 40. So this greater than or less than sign is very, very important to understand, because this is a very, very handy tool in set builder notation. Okay, so this is it about set U. Now what about set A? Set A says that it is set of X such that X is a prime number. Now we need to understand what prime numbers are, all right? And prime numbers are nothing but numbers that can only be divided by 1 and themselves. Alright, so any number that can be divided by itself and 1 only, that number is a prime number. So now, set of prime number. Now, remember that in this set A now, we are not given boundary. Unlike in the case of set B, we are given boundary for the set of numbers. Alright, but in the case of set A now, we just set of all prime numbers. So it means that we are going to write out the set of all prime numbers for set A. Alright, therefore A is going to be set of all prime numbers, and the first prime number is 1, because 1 is a number that can only be divided by 1 and also itself, it is still 1. But of course, in most times 1 is not really regarded as a prime number, but 1 is a prime number even because it can be divided by 1 and also itself, so 1 is a prime number. Another prime number in the list is 2, because 2 can be divided by only 1 and itself. The next one is 3, a prime number. Alright, and of course 5 is a prime number, 6 is not a prime number, 7 is a prime number, 8 is not a prime number, 9 is not a prime number, 10 is not a prime number, 11 is a prime number, 12 is not, then 13 is a prime number, and so on and so forth. Alright, so this is set U, this is set A. Okay, now what about set B? So now talking about this set B is a lot, or maybe a little bit intuitive or a little bit confusing, but we really need to pay very close attention for us to know the set of numbers that this set B in this set builder notation is talking about. Alright, so set B is set of X such that whatever thing X will be a number such that when you square it, its outcome is going to be less than 36. Let me say it again. Set B is set of S such that whatever thing that is going to be this set of number X will be a number that when you square it, it will not exceed 36. Alright, and of course now looking at it now, let us attempt to explain this using a number line. Like this. If this is a number line, for instance, and here is 0. Alright, here is 0. So this is 1, 2, 3, 4, 5, 6, 7, and so on. Here this is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and so on. Now, if you watch carefully now, assuming that there's a set of numbers, let them be these integers. Of course, numbers on this number line are integers. So from this plus 7 now towards here is towards positive infinity, and from this minus 6 now down is towards negative infinity. All right. So if I take x to be 1, positive 1, if I square it, I will have 1, which is less than 36. So 1 is inclusive. If I take x to be 2, if I square 2, it will still give me a value that is less than 36. Square 3 to give me 9, which is still less than 36. Square 4 to give me 16, which is still less than 36. Square 5 it will give me 25, which is less than 36. Square 6 it will give me 36, which is equal to 36. So therefore means that this one is also, this one from here now down here is included. From here down is included. From here now, from 5 down is included. But from 6 upwards towards positive infinity is not included. But let us know where this one ends on this number line. Again, of course, if I take x to be 0 and square 0 to give me 0, which is less than 36, very important. If I take x to be minus 1, square minus 1 is give me 1, which is less than 36. So it therefore means that 1 is included in this set of x. Now, what about if x is minus 2? If I square minus 2, I have nothing but plus 4, which is less than 36. Square minus 3, I have plus 9, which is less than 36. Square minus 4, I have plus 16, less than 36. Square minus 5, I have plus 25, which is less than 36. Square minus 6, I have plus 36, which is equal to 36. So that means that this thing ranges from 5 down to minus 5. So in other words, set B is actually set of numbers from negative 5 to positive 5. I hope you understand this. Alright, so this set of numbers is actually numbers from minus 5, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. Okay, so these are the set of numbers. So it is only this set of numbers that when you square it, its outcome will be less than 36. Any other number apart from these numbers inside this set B, if you square it, it will give you either greater than or equal to origin. Of course, either greater than or equal to this set. But it is only these numbers now that is square gives you a number less than 36. Hence, the set is actually this. So this is the set. This is set B in the listing method, and this is set B in the set builder notation. Please take note of that. Let me just clean this. So I just thought to use this number line to focus on this point. Okay, now finally set C. Like we are asked in this set C that we should just write out the elements that are contained in this set C. Let's just read the set again. Set C is set of X such that X is an element of U and X is not an element of A. Meaning that this set called C, this entire set now called C, has its element to be X. And now this element X is also found inside U. No wonder this set is said that X is an element of U. That is, whatever element C as a set has is also found in U. Because we say that X is an element of U. So the elements of this set C are also elements of set U, but they are not elements of set A. This is very, very important. So it therefore means that we can say, now since the elements in set U are also found in set C, it therefore means that set U is equal to set C. Very important, because if X is an element of U and the same X is an element of C, it means that if X is an element of U and X again is also an element of C, it means that U and C are the same. And now, like we have seen initially, we have seen that set U has these elements that is ranging from 6 serially down to 40. So it means that is the same set. This set of number that is contained in set U is also contained in set C. Alright, therefore set C is actually this, which is 6, 7, 8, 9, 10, down to 40. Then we close. Okay, let me just quickly explain what I mean by this dot. Alright, so set C is set of 6, 7, 8, 9, 10, 3 dots, then 40. Meaning that these 3 dots includes all the whole numbers, all the numbers between 10 and 40. So because of space, we had to kind of just put it that way. So whenever you see 3 dots, it means that it is kind of trying to account for the numbers you actually omitted. Very, very important. So this is it for set U, set A, set B, and set C. So please take note of this and let me just know your comments. You can share your observation if you have any. Just share it in the comment section. So now this is question 4 actually. So we are given these informations and we are asked to provide the answers to this. Let's just read. It said, let U be equal to this set in a set builder notation. And let set A be equal to this, and set B equal to this, and set C equal to this, as well as set D equal to this. Then we should find the following. Alright, that is find A union A, whatever answer it is, put the answer there. Then find C complement minus, that is difference of C complement and C, then intersection B union A, whatever answer it is, you find, put it down here. Then find the answer to this is A complement union, then relative complements of C and D, then take the complement, then whatever answer you have here. So of course this is our C. So this C means complement of A. So this, take the difference of these two sets, then take their complement. So that's what this C means. Alright, then next one says set of 5, 2, 3, and 4 intersection sets of C minus D. Whatever answer you have, put it in there. The next one is A intersection C, then into union D. Whatever answer we have, we should put it in there. But first, we cannot do this effectively without we, first of all, writing out these sets, especially set U, set C, and set D. Especially these ones that are in the set builder notation, writing them out in a listing method. Of course, it is very easy for us to look at set A and B and deal with them, alright? But you see set C, set U, set C, and set D. These ones are a lot more tasky. Alright, so we need to write them out in their listing method before we can start anything we are doing. So let's quickly draw a line here so that we can use here to do whatever thing we are doing. Let us use here and write out our set U. Now, set U is set of S such that 6 will be less than or equal to X and X will be less than or equal to 40. So this is similar to what we've seen before. So whenever you see something like this, it's trying to tell you that this set U, the universal set in this case, ranges from 6 to 40. And of course, this set builder notation gave us additional information by telling us that this whatever thing X is a positive whole number. Alright, and of course you should know by now that whole numbers are numbers on the number lines that is specifically from positive 1 down to positive infinity. So from 0 rather down to positive infinity. But 0 is not included here because the condition here obviously excludes 0. The condition here specifically states that the set, that is whatever X is, ranges from 6 to 40. So we're going to have 6, 7, 8, down to 40. So this is set U. Alright, of course you know what this 3 dot means. Next set we need to have here, we already know what set A, set B. Now what about set C? Set C says that it is set of X such that X is an integer and 2 plus X plus 1 must be equal to 5. Now it has given us the first information talking about set C now. X is an integer. We know what integer is. Integer could be positive integer. Integers is nothing but all the numbers on the number line. All of them are collectively regarded as an integer. Hence, we can have positive integer, negative integer. But here, we are told that X is an integer. Now, to make it more specific, we are told that 2 plus whatever thing X will be, 2 times whatever thing X will be plus 1 must be equal to 5. Now, you now check on the number line which integer that will multiply by 2 added to 1 will give you 5. And it will be nothing but, if you check 1, if you put 1 here, 1 times 2 is 2 plus 1 is 3, so it's not equal to 5. If you take 0, it won't work. If you take 2 times 2 is 4 plus 1 is 5. So it is only 2 that can work. Therefore, set C is nothing but 2.
right? Therefore, set C is just 2. So all these things you see written in a longer way is just 2 that is inside that set C. Next one, set D. Set D says it's a set of S such that X is a positive integer. Very important. And S squared over 2 is equal to even numbers less than 10. That is, this D is set of S such that that S is a positive integer, and whatever X will be, when you square it and divide by 2, it will give you an even number that is not, sorry, that is less than 10, or maybe, or rather, that is not greater than 10. Very important. So 10 is not included. So remember that this symbol is very important. Had it been the set of equal to here, it means that 10 will be inclusive. So it means that we are going to check for sets of positive integers that when we square and divide by 2, it will give us a number that is not, that is actually less than 10, not, that is less than 10 rather. So we are going to say that D here is going to be, so first of all, we take a positive integer, because we're not going to look at negative integer now, because it has said positive integer. It is very specific in this case. So we're going to be choosing positive numbers only. So we're not going to be taking any negative number. So 1 squared is 1 divided by 2 is 1 over 2. So 1 over 2 is not an even number. Even though it is less than 10, it is not an even number. So we move over to 2. So 2 squared is 4. 4 divided by 2 is 2. And it is less than 10 and it is an even number. So 2 is a more. 2 common. Next one is 3. 3 squared is 9. 9 divided by 2 is also a fraction, and of course it's not an even number. Next one is 4. 4 squared is, if you put 4 here, 4 squared is 16. 16 divided by 2 gives us 8, and 8 is less than 10, and of course it is still an even number, so 2 8. Next one is 5. 5 squared is 25. 25 divided by 2 gives us a fraction, and it's not an even number, even though it will be less than 10 or greater than 10, but that means that this set is a set and there's no other number we can take. So set D is actually set of 2 and 8. Set C is just 2. Set U is this. Set A and set A and B are these two sets. Now we can now proceed into answering these questions. Remember, we finished the first part of the question, which is writing out the sets in the listing method. Writing out those nodes that are in the set using notations into listing method. So we can now proceed to finding this. Now the first question here says find A union A. Now A union A, remember what union of a set is: the addition of the elements in two sets without repeating any one that occurs twice. So that is union of a set. And of course, one of the idempotent rule, or one of the rules in set, says a set union itself is equal to that same set. And again, a set intersection itself is still equal to that same set. So on the strength of that, we can now say that A union A is nothing but A. It's as simple as that. Yeah, so we are done with the first. Then the second one now says, now for us to tackle this problem here, there are a lot of things to deal with. First, we are going to find the complement of C. So let's first of all find C complement. C complement. Now, talking about C complement, we know what C is. Now, we are going to relate, for us to get C complement simply means what are in the universal set U that are not in the given set. So we are going to get C complement by taking these two sets, universal set and set C. So whenever we cannot be asked, it is impossible for us to be asked to find the complement of a set if the universal set is not given. So since the universal set is given here and we are given set C, we can confidently find the complement of C by writing out all the elements that the universal set have and set C does not have it. And the only thing set U have and set C does not have is still this universal set. So we can say that C complement is still equal to the universal set. Very important. Because the universal set has all of this number ranging from 6 to 40, but C does not have it. C only has only 2. So C complement is equal to the universal set. Next thing to be found from here is what C is. C is actually this. Alright, so now, therefore, since that we've gotten what C is, we can now say that C complement minus C is equal to what? That is, C complement minus C is more like saying universal set. C complement minus C is more like saying it's a kind of taking the relative complement between these two sets, or finding the difference between these two sets. So what it means is, whatever now set C complement and set C, take what both of them have in common take it out and write out what remains. Alright, so these two sets now, remember that set C complement is something as set U. Very important. So these two sets now, what do they have in common? Whatever thing they have in common, take it out and write the answer that is remaining, or going to write out only the element that is remaining in the first set mentioned. So they do not have anything in common. So the answer I'm going to have here is what this one has. So which is nothing but still set U. Alright? Okay, so C complement is still U and C complement minus C is still set U. Now, next thing to be done here is now say that therefore C complement minus C intersection. Okay, but first, before I do that, let me find B union A. Now, B union A is actually, now look at B, look at A. So these two sets, I'm going to take their union. So B union A is actually adding up both of them together, writing all the elements in these two sets without repeating anyone that occurs twice. So I will have 1, 2, since there are 2 here, so I'm going to take 1, 2. There are 3, there's 3 here, there's 3 here, take 1, 3, 4 here, 4 here, take 1, 4, 5 here, 5 here, take 1, 5. So I'm going to have 1, 2, 3, 4, 5. Okay, so this is B union A. Therefore, now finally, therefore, C complement minus C union B, C union, no, intersection rather, intersection B union A is equal to what? Now, we've already seen that C complement minus C is equal to the universal set, which is this set of number here. Now, B union A is actually the set of number in here. Now, their intersection will now be, now for us to find this now will be this numbers, this set of number in here and this set of number in here. What do they have in common? So that is what intersection of set means. So intersection of set means the number that the two sets has in common. Alright, so what does this set and this set have in common? So if you check very carefully, they do not have anything in common. This one actually started from 6. Alright, but this one ended at 5. So this one didn't even get up to 6. And if this one got up to 6, the answer would have been 6. So they do not have anything in common. So the answer to this is nothing but empty set or no set. So you're going to have empty set here. Or you can represent it this way, no set. So this means empty set, this one means no set. So either empty set or no set is the same thing. Okay, next question is to find this. Very, very important. So let me quickly clean off this part. So you can take the notes. Do well to take the notes. Very important. It will aid you. And you can rewind the video as many times as you can to understand the concept. Next, to find this now, we need to know what a complement is. Now, remember, like I told you, for you to get a complement of a set, you must get it with respect to the universal set given to you. Now, we have our universal set as this, and we have our set A as this. So, now, for us to get a complement, it will be write out all the elements in here that are not in here. Write out all the elements in this universal set that are not in here. So, it means that on the course of writing out the elements in the universal set, anyone that is also in here, I'm going to avoid it. So, if you watch carefully, this two sets they do not have anything in common. So therefore means that this A complement is still going to be set U. Very, very important we understand that. Now, next thing to be done now from here now is to find A minus D. Sorry, C minus D. C minus D. So that is the relative complement of these two sets. And after that, I will not take the complement. So the difference between these two sets is actually this. So now I will be having okay, so talking about the relative complement or the difference between these two sets, it will be looking at this set C and set D. Look at set C, look at set D. Take out what both of them have in common and write the answer that is remaining only in set C. That's the first set mentioned. So what is common in these two sets is actually 2. So I'm going to take out these 2. Now after that, what is now remaining in set C is nothing. So if I take out what both of them have in common, this set C will not be having any other thing. But the rule says after taking out what both of them have in common, write only the answers that is remaining in the first set mentioned. So the first set mentioned here is this set C, because C actually came first before D. So that means that this one is going to be empty set, or call it null set. Very, very important. So the relative complement or the difference between these two sets is what? Empty set or null set. Next thing to be done here is to find the complement now of this set. That is complement of C minus D. So what is it going to be? Now, remember that this C minus D is actually empty set. Now, it means that the complement of an empty set, remember how we usually find empty set? Sorry, complement of a set, I need to say. Whenever you want to find complement of a set, you have to get it with respect to the universal set. So, the complement of this empty set, which is something as this, is going to be what is it in this universal set that is not in here? Obviously, there's nothing in here. So the answer to this now is going to be everything in here. So the answer to this is going to be the universal set. Very, very important to understand. The next thing to be done now is to take the union of this. Since we've gotten A complement to the universal set, and the whole of this to still be universal set, we're going to take the union of these two. Therefore, now, A complement union C minus D complement is going to be what? Universal set. Because this is a universal set, this one is also a universal set. And don't forget I said at the inception when we are talking about this that a set union itself is equal to that same set. So universal set union universal set is still equal to universal set. So the answer to this is still universal set. Okay, universal set U. Or if you want, you can write out all the elements in here. All these elements, all this number in there, maybe from 6 to 40, are all what you should write in here. But if you still leave it at U, which is universal set, you are still very correct. Okay, next thing to tackle is this second to the last. So let me clean off this place and quickly solve that. Make sure you take notes, very important. So next thing now is this. So first, let us find C minus D. And of course, I think we found C minus D somewhere here before. We found C minus D. C minus D will be equal to null set. C minus D is equal to null set because this is it now. Then now taking the therefore set of 5, 2, 3, and 4 intersection empty set or null set, what do you think the answer is going to be? So if these two sets are to intersect, taking the intersection of these two sets, it means that intersection simply means what do they have in common? Write them out. And of course, this is an empty set, and this is a set of number, maybe 5, 2, 3, and 4. So they do not have anything in common. So the answer is still going to be empty set. That null set or empty set. Alright, so that is all we're going to have here. Null set or empty set. Okay, so finally, what about the last, which says A intersection C union D? How are we going to tackle that problem? So first, let us find A intersection C. So A intersection C. What do I or what am I going to have? So set A is actually this, and set C is actually this. So what do set A and set C have in common? Obviously, they have 2 in common. So A intersection C is nothing but 2. Okay. So now I've gotten what A intersection C means. So I'm going to now say, therefore, A intersection C union D. What am I going to have? And of course, set D is this. So therefore, it's more like saying 2 union this. Alright, so union of set means write out all the elements in those two sets you want to take their union. And don't forget not to repeat whichever one that occurs twice. Or in other words, don't repeat whichever one that occurs twice. So there's 2 here. Even though there is 2 here, it does not mean that I'm going to write 2, 2 and 8. No, I'm going to only write 2 and 8. 2 and 8. Okay, so this is the answer. So finally, I'm going to have that this is set of 2.8. Okay, so thank you for staying tuned. So do well to take down the notes. Very, very important because even though these are practice problems on the set, please don't forget to take down the notes and do well to subscribe to this YouTube channel. Turn on the notification bell so that you'll be notified whenever I upload a new video. And do well to like the video, like this video so that YouTube can recommend it to many other persons. And do well to share your observations in the comment section below. I'll be very eager to see your comments. Very, very important. And of course, take down the notes and that will be it for now. Next time we are going to be maybe in our next video I'll be releasing we are going to be looking at question number 5 under the same set operation. Thank you.